that we expect to realize by 2023. Together, we've leveraged these capabilities to find solutions that improve military readiness and cost effectiveness. We estimate that CTMA will save that amount of money by 2023. And that does not include the cost of keeping more weapons platforms ready to protect the men and women of the armed services. In other words, how can we put a dollar value on increasing the effectiveness or giving increases the benefit of having our weapon system having increased availability, is the word I'm looking for, to our armed forces. Proudly, CTMA projects have earned the program the following awards. We've had 10 Defense Manufacturing Excellence Awards. One might be pending for this year. 2 Great Idea Award winners, 2 R&D 100 awards, the NavAir Innovation Award, American Helicopter Society Jensen Award, the Air Force Chief of Staff Team Excellence Award. Next slide. All right, a little bit about the number of projects to date, just to give you some feeling for the scope of the program. We've completed 215 projects and have 41 distinct DoD facilities participating. The DoD funds expended to date are total around $129 million. And industry in kind is totaled so far about $182 million. The project participants by service break out this way: 52 projects with the Air Force, 47 projects for the Department of Navy, 64 projects for the U.S. Army, 51 projects for the Marine Corps, and 1 project for DLA. The annual potential cost benefit to DoD, as we said earlier, is about $4 billion. And those stats change constantly. That's a fluid number. Well, that's it for our morning's introduction to NCMS. We wanted to give you a little bit of flavor of the CTMA program and our partnership. What I'd like to do now is introduce Greg Kilchenstein, who is the, you want to put up the next slide? You got it. The Director of Enterprise Maintenance Technology in the Office of Maintenance Policies and Programs. Greg?
Thanks, Connie. Really appreciate that. And also, thanks for the shameless plug for CTMA. If anybody doesn't understand or know CTMA, we are open for business. We keep expanding. We keep doing good things for the maintenance enterprise across the board. Additive manufacturing is a piece of that, but we're in the business to drive maintenance effectiveness and efficiency through technology across the board. In my role as the Director for Enterprise Maintenance Technology and also as the permanent co-chair for the Joint Technology Exchange Group, it's my job to look at ways to improve the maintenance enterprise through the application of technology. When I say improve, I'm talking about improving the effectiveness of maintenance, the accuracy and the precision of maintenance, the reliability that we drive out of maintenance, as well as then the readiness of the weapon systems. Our mission here in OSD Maintenance Policy and Programs is to set the framework by which we can maintain the readiness of America's forces. And it's not just the military side of the board that we're maintaining, but it's also the humanitarian side of the board that we're maintaining as well. So our folks are currently in the Philippines. Our hearts and our minds and our prayers go out to those folks in the Philippines today, but America's forces and the systems that we provide to America's forces are out in the Philippines today doing our work and helping those people in the Philippines. So that's our mission. You know, Mom always said that matters first, so I'd like to take this time to really thank our partners at the National Center for Manufacturing Sciences for all the hard work that's gone into putting this virtual forum together. There's a lot that goes into these things, and we have 150 people connected today from around the country, and I think we even have a couple international folks out there. And I'd also like to thank all the 150 participants or greater that we have out there today, because a workshop's not really a workshop unless we all show up to the table and roll up our sleeves and look for opportunities to do this better than we have been up to this date. We all know that, especially in this crowd, that technology plays a key role in maintaining America's forces. Up to this point, over the last decade, our mantra has been readiness at any cost. That has to change, and it's changing very rapidly. Our mantra now is readiness at best cost. I don't have to tell you about the current fiscal environment. We've all felt it. I don't care where we're coming from, whether you're coming from industry and you're seeing less funding in terms of contracts, or you're coming from academia and you're seeing less grants coming in, or you're from the government and you've been furloughed, or you have less maintenance funds available, less RDT&E funds available to execute your mission. And the outlook and the prognosis for this situation is really not getting any better anytime soon. In fact, it's going to go the other way. Maintenance in itself is about an $80 billion annual bill to the Department of Defense. The logistics enterprise is roughly $200 billion annually, which is around a third of the total DoD maintenance budget, or DoD budget, excuse me. And those figures have doubled in the last decade. Since 2003, those figures have literally and figuratively doubled. And that has to stop. So here we are, we're at this precipice of this perfect storm where maintenance costs are on a significant increase, almost an asymptotic rise. And the available resources for maintaining America's forces are coming down significantly and rapidly. And if this trend continues this way, the projected outcome is not good. It will result in lower than required material readiness, again, to support the military objective as well as the humanitarian objectives of the department, and ultimately will result in the inability for DoD to meet its national security objectives. If I asked 99 out of 100 maintainers in the field, if I could do anything for you today to improve your maintenance effectiveness and efficiency, what would that be? And I can guarantee you that 99 out of 100 of those maintainers would tell me, if you give me the parts that I need at the locations I need those parts, at the time I need those parts, and make those parts affordable to my enterprise, I will turn out quality product, reliable product to meet our readiness goals and missions. And because of the additive manufacturing's potential, again, to greatly reduce lead times for parts, to reduce parts cost, to provide increased accuracy and precision in the manufacture of those parts, and its ability to address both the new, more complex, really complex weapon system parts and components, as well as the legacy system parts that we have that are facing obsolescence every single day. And facing these challenges head on, the maintenance community has been engaged with and supportive of, and in a way kind of driving from the rear, if you will, the additive manufacturing community, since practical applications for additive manufacturing have become evident beginning in the early 1990s. Although our partners in the research, development, technology, and engineering community are driving the development of the technology for additive manufacturing, the processes, the material qualifications, the certifications, the machines, the maintenance community has been the early adopters of these capabilities, where transition for these capabilities has been the most profound and immediate, and the impact on the warfighter and the readiness of their equipment. Today, all of our major maintenance depots now possess some level of additive manufacturing technology, encompassing a full range or full spectrum of capabilities, from things like flame spray and now cold spray for repair of components to more advanced laser sintering 3D printers. And the results, though, at this point have been limited. They have been profound. I like to tell the story of the first Gulf War and additive manufacturing, or the lens, laser engineered net shaping capability that we quickly stood up at Anniston Army Depot back in the early 90s to accommodate the first Gulf War. And the story there is that the M1 tanks operating in that desert environment, the engines on those M1 tanks, the AGT 1500s, were experiencing extreme amount of wear and tear. And because of that extreme amount of wear and tear, we could not keep up in the maintenance cycle with the parts required to keep those AGT 1500s in those tanks. And so through laser engineered net shaping, we were able to save a lot of the components, or some of the rotating components, in those AGT 1500s and keep those tanks on the battlefield and ultimately march on to, at least first round of victory in the Gulf. Also, when we're having problems now with obsolescence, a lot of the cast parts, as casting sources, are getting out of the military business and moving on to other parts of the casting business. Additive manufacturing capabilities have helped us now address those issues through providing sand casts for those parts. Also, in composite materials, the composite material layups and the molds required to make those, we're able to quickly and rapidly make those molds and those casts for those composite materials. 3D printing of low volume, long lead time, and non-structural parts have played a key role in keeping our submarine fleet and our seagoing fleet working through Keyport and Kings Bay and their capabilities. And we have countless flame spray and now cold spray repairs that we're doing and saving, again, untold millions of dollars in saving parts rather than scrapping parts that we heretofore could not repair. So as we lay these things out, so why are additive manufacturing capabilities not promulgating with the speed that their potential would indicate? And there is really no one easy answer to that question. The answer really lies in awareness, confidence, and cost. Awareness of the state of the technology, from the artisans on the depot floor all the way to the commander of that depot, to the program managers and their product support managers in the PEO's organizations, to the highest levels of the sustainment leaders in the military services and OSD. We have to generate the kind of awareness for what these capabilities can provide and what the upside potential is for these capabilities across the board. We have to generate confidence in the processes and the products that they produce, confidence that comes from experience, and it is a direct correlation of the number of impactful success stories resulting from additive manufacturing solutions. And cost. The cost of the tools and machines is expensive. There's no doubt about that. But the real cost, the biggest driver to the cost, is not the cost of the tools and the machines, but it's the cost of the qualification and the certification of the processes, materials, and parts produced by an ever-widening array of additive manufacturing capabilities and technologies. Program managers and depots simply don't have the money required for the additive for the qualifications of the additive manufactured parts produced in order to ensure the performance characteristics of those parts or the safety margins required for their users. In order to transition additive manufacturing more rapidly, we cannot afford to go it alone in our silos of excellence, which brings us really to the objective of today's workshop. Our goal to strive for, a kind of a lofty goal, is to expedite the adoption of additive manufacturing capabilities in the maintenance and sustainment community via a focused unity of effort. Our journey toward this lofty goal, we must expand our awareness of the technologies, processes, and outcomes that are currently being employed by our depot operations and sister agencies such as NASA. Our morning session for this meeting is dedicated to this objective. We're going to hear perspectives from subject matter experts that are actually doing this at NASA, in aviation maintenance, in sea system maintenance, and in ground system maintenance. In the afternoon, we'll have technical experts who will discuss the progress toward the essential building blocks that will ultimately enable expanded and accelerated adoption of additive manufacturing capabilities. And then later in the day, we as a community will discuss the ideas that will further enhance the transition of this game-changing technology and explore opportunities to contribute and help lead this additive manufacturing revolution. We've been very pleased, if not a bit overwhelmed, by the outpouring of support from industry, academia, and the DoD for today's additive manufacturing workshop. But as I mentioned earlier, it's only a workshop if we participate and interact as a community. Our partners at NCMS have gone to great lengths to enable and facilitate this workshop using some of the best virtual tool suites available today. I encourage each of you to use this venue to share your ideas, provide the energy and enthusiasm, and take a close hold on the reins to help focus and steer continued adoption of additive manufacturing in support of maintenance and sustainment. And with that, I guess I'll hand it over to Andy Perich from RDECom, who's also representing the Joint Defense Manufacturing Technology Panel, if he's available on the VTC at this point.
Slide.
Yeah, hi, this is Andy Perich. Can you hear me okay?
We can.
We got you, Andy.
Oh, great. We were able to hear Greg talk for a while. I'm sorry?
There you are.
Yep,
Okay.
we got you.
Visual is now up.
Okay.
Looks like you're working.
Now I'm standing. Oh, now we can see us too. Okay. All right. Well, thank you for letting me present. I'm presenting on behalf of Steve Luckowski, who was our member on the JDMTP subpanel work group for additive manufacture. So we're going to try to give you a little insight on what we believe are the Army's role, or the RDECom role, is in additive manufacturing. So if you go on to the next slide. Thank you. This is really just an introductory slide, and I'm sure many of you have seen it already. But it tries to represent that additive is just a process of joining materials, and it's just a new way of doing that. So the challenge that we have as we move out from the older processes to the newer processes is how do we change over to allow this technology to filter into our existing manufacturing processes, and more importantly, to the engineers that have to accept the technology as a replacement to current technology. So go on to the next slide. Okay. So what we have is many technologies that I'm sure most of the people in the audience are familiar with, but the ASTM F2792-12A defines the additive that we'll be discussing today as these technologies: powder bed fusion, directed energy deposition, material extrusion, VAP polymerization, material or binding jetting, and sheet lamination. So go on to the next slide. Okay. So there's, from our point of view, or from the Army point of view, these are the benefits and challenges that we tried to take from the DoD strategy and incorporate it into our language, so we can look at what would be the benefits to our customers here, and what would the challenges be to implementation of the technology. As you all know, the end goal of an additive is to basically be able to take a concept from a model directly to a printed part, and to look for the opportunity to bring that into the processes to replace the existing parts that we have, and to look at new ways of designing. The challenges that we have, and we're going to talk a little bit more about that in a little while, is the machines have limited surface finish, dimensional accuracy, and these are the challenges that we're trying to look at and develop a strategy to solve. So go on to the next slide. All right, so the point we wanted to make is how do we support the JDMTP? RDECom is the Army's representative to the JDMTP, and we're working very hard in the additive space to try to develop emerging and draft industry additive manufacturing standards. That's our way to address the certification issues. If we can come to an agreed-to set of standards, then it will be a way to fill the gap in industry, a way to make sure that the Army and DOD source documents are there to help with the industry standards, and we work together on how to make AM a reality. We're working with DARPA and Open Manufacturing. It's a program where we're looking to have a virtual connectivity of the industrial base, and some other programs that the NAMI, which you're probably all familiar with much more than I am, which is the President's America Makes program. So we're participating as a technology advisory board, and we're providing the technologies that we need to in this specific for investment program calls. Go on to the next slide.
You gotta go 2 slides.
Oh, I'm sorry, 2 slides? Oh, so talking to the wrong slide? Okay. That was a slide ahead, I'm sorry. The main point of this slide is in DOD, or within the Army, we touch just about every technology and every manufacturing need there is in industry or anywhere worldwide. We go anywhere from very small fuses within a munitions world, which is what we do here at RDEC, to UAVs, UGVs, helicopters, individual soldiers. So there's not any manufacturing need that's not represented by an Army system. So that gives us a lot of opportunity to look for those test cases that will really give additive the springboard it needs to go forward and start solving real problems and be the market driver, if you will, to then look at more opportunities. So, go to the next slide. Okay, so if you look at this slide, this is basically our applications roadmap. Right now, we see in the current year we're working in that the best opportunity we found for AM is in rapid tooling and rapid fielding support. The technology seems to be available to support an existing manufacturing process, casting, tooling for casting. So it's easy to embed and learn more about how rapid tooling can help us in that rapid prototyping of those type of parts. We're looking to get into more tooling and repair. Then the more applicable topic for today's discussion probably in your workshop is part substitution. How do we look at the existing parts that we have in our tech data packages that the depots and arsenals have to manufacture too, and how do we start doing a part substitution? And that's where you're getting into a lot of the issues with material certification, which again we'll talk about in a little bit. Then once we understand that we can do part substitution, then how do we bring that certification process back to the manufacturing processes so we can tie parts to the process and do a certification around both, that we can show that a additive part can meet the objectives of the TDP and can be a direct substitution for a part that's not called out on that technical data package. That is a very, very difficult problem. And then we'll have the end goal of 2018 would be an integrated design and manufacturing using AM. The real benefit to AM, once we can educate our engineering community on this new tool and new technology, is they can actually go back and rethink how they design our parts. Similar to what GE is doing in, you're probably all aware of, in the engine components. You could actually take a step back and look at, well, what is the functionality of a fuse? What is the functionality of this fabricated part in a munition? What is the train that has to be done for safe and arm? And how can we take advantage of this new capability where using the old techniques, they were not producible. Now with this new technique, they are producible. So how would we redefine how do we do our designs and move forward to get something totally new to meet that space. Go on to the next slide. All right, so I guess from the JDMTP point of view or the Army point of view, we have a 30,000-foot view. We're trying to define the actual requirements for additive. That's why this workshop is very good for the engineering community here at the RDECom. We always looked at ourselves to be the front end of the industrial base. We are the engineering support activity for the PMs in that vein of engineering. We have the product knowledge all the way from concept, all the way through development to full-scale production, and once it's out of production, to how the depot work maintenance requirements are put together to meet the objectives of the requirements of that system. So in that role, we're just trying to see, okay, how does additive fit into that total lifecycle engineering problem? Once we understand that, how do we help direct Mantech or other Army investments, and how can we leverage opportunities from other sources? There's you look at like GE in their helicopter engine plant, they're investing $3.2 billion into their new processes for the new engine to include additive. It's very hard for the Army to throw that type of investment at any particular area. So how do we exploit what's going on in industry and marry it with what we need in the Army? So at the 10,000-foot level, which we're coming down to the RDECom level, we really have to start dealing with very strongly how do we deal with material and process certifications and qualifications. We're a risk-averse industry. Our PM's job is to make sure our systems are reliable, that when they go to the field, when they pull the trigger, it's going to go boom and not click. So we have to educate that community who are comfortable with the older processes and make them comfortable with this new process, that they will be reliable, they will function, they will do what the system has to do when they change over to the additive. The way to do that in the engineering community is with detailed certification processes and qualification testing. I hope I don't insult anybody in the audience right now. When I say qualification, I look at it from a engineering point of view as well as a researcher's point of view. Clearly, the science allows us to look at the very small particles that we're using for additive and the welding between the two. But what is the current state of technology in being able to investigate how good a product is? And we can't go down to the fear of a void between each individual particle being welded together and looking for a welding void. You have to bring it back to what's realistic in our community to be able to inspect, and then how does that relate to the existing products. The way forward is to develop a knowledge base of the additive materials. What we've done in other areas in our chemical industry, we've looked at how do we certify the raw material, and then how do we certify the process. And if you can certify the raw material and the process, and there's a check on the end that the product is coming out the way you expect, then you can get some relief over the qualifications that you would need to retest the whole system. So in our world, that would bring us back to a first article test within a production environment or a lotting environment, but it would allow us to not have to go to full system qualification. Of course, we're hoping once we understand the raw materials and we understand the process, through that understanding we can improve the machine performance to meet the needs of the products that we're trying to do. And how do we collect that information in an enterprise way to be able to transfer what we've learned in the engineering community to the production community and also to the depot and maintenance community. So that's the 10,000-foot view that I guess where we sit in RDECom, we feel very comfortable in that's the vision that we have to go. So at the ground level, with the guys sitting next to me, I don't know if you see them, but they look like workers and I don't. They're starting to deal with how do we do standards development. We have people on the team, and we just lost connectivity to the DCS. We have people in the materials lab sitting here, and they are running our additive processes, and they're trying to deal with material testing and certification, and through our Mantic program, trying to get a better understanding of that. We're always looking for candidate parts and substitutions right now. We've certainly done well in the area of in plastics, but we are now looking at cast parts to maybe that we could use as a sample to use an additive process. And we are doing some level of redesign in fuse trains to see if this new technology allows us to do something different. We're working with NIST and other folks to work using existing databases, and how do we expand those databases to meet our material and process info needs. RDECOM's role, the Navy and the Air Force, they have their engineering centers as well. We always look at ourselves as the front end, like I said, the front end of that industrial base. And our mission is to transfer whatever knowledge we come up with these new manufacturing technologies to both industry and our organic capabilities. So there's a lot of effort going on to communicate more with forums like this to do that better. And we're doing many demos of processes, and we're very interested to learn what everybody else is doing out in this community. All right, so just to summarize, the emphasis area that at the ground level we want to focus on is tooling and repair, spare parts. Low volume alternatives are small, highly intricate part alternatives, and that would be the novel design. So when something like a fuse component, the beds on existing, hello, you're on the screen. The beds on the existing additive machines do allow us to do a larger volume production in small component things like a fuse product. I go to the next slide. Am I running out of time? That's why I'm off the screen. Okay.
No, you're good.
Okay. So in summary, and then I'm going to go on to some of the backup slides if we could. We all understand that additive is an enabling technology. We've been through enabling technologies many times in our history as a manufacturing community and as a government, and we do know how to bring a new technology forward. And we're just hoping we can expedite that a little bit faster than in the past, but this is nothing new, and we community can do that. I'm sorry, someone else is on. I'm getting a lot of back talk. Okay. Additive manufacturing aligns with our goals. Right now, we've done a lot of rapid fielding and prototyping in support of the warfight. And additive is one way for us to do that. Initial prototype to give that demonstration to the soldier directly in the field of what we can do with a technology solution. So we feel that additive is actually critical to the asymmetrical warfare threat, if you will. If we have an ever-changing enemy, how do we change quickly, or how do we give some kind of evolutionary change to one of our existing products to meet that new threat? Additive gives us that quick capability. We're developing an enterprise-wide strategy, and as our plan goes forward and develop, we're looking for people to help us out with that development. The one area that I wanted to touch on, if you go to the backup slides, if they're in there.
Hi, Andy.
Yeah.
This is Debbie here at NCMS. Hi, Andy.
Okay.
This is Debbie here at NCMS. Just for the sake of time, can you review the backup slides a little quickly, if you don't mind?
I was only going to do the first pillar. Okay, I'll just do the first pillar, and that's the material and process certification efforts. I just wanted to show that we're working on a lot of industry and working groups. I'm just stressing this because I think this is very critical to making additive a reality. So if there's anything in the message that should have gotten across to Steve Luckowski, And our ECOM headquarters, it was to make the point that it's the certification that's our biggest inhibitor to going forward right now, and the qualification and making this a reality. All right, so with that, I'll just stop, and I'll let you move on.
Thank you very much, Andy. We will have your full set of slides made available to everyone who is registered for the workshop session. And we might have an opportunity later in the afternoon to come back to some of your points, because you've got some very good points on those backup slides. All right. Greg, did you have anything to add before we close your session?
No, Connie, I'm good here. I just, again, like to thank Andy for a really great overview, and we will be getting to those pillars, Andy, as we go into the afternoon and start to talk specifically about those building blocks, those enablers for more rapid, more effective transition of these capabilities. So we look forward to your perspective this afternoon.